All right, so we got 2.1, and our learning goal is we're going to use integers and rational numbers. And you guys would have been introduced to this last year, and this, for some of you, is probably kind of simplistic, but I want to make sure that we go over it. Yes, there's nothing strange. It's going to teach under here, and then they're going to magically see it here. Okay, so we're going to start off by graphing on a number line, which again should be completely review for you guys. So I've already put the number line on here for you. I want you to go ahead and graph these three numbers. And when we graph, we just go ahead and we put the dots directly on the number line, because that's how we would graph if this was a x and y. This is actually just like an x-axis graph, because we're missing the y that goes up and down. Okay? Obviously, if we go in and graph this, we have -8. We have 7, and this is counting by 4s. Now let's see, 4. This would be 6, so it's going to be halfway in between here, and -3. Okay? Number lines are helpful sometimes when we're putting things in order, because remember, this is all smaller numbers as we go negative, and as we go positive, they get bigger. Okay? All right, before we go any further, let's go ahead and talk about a few vocabulary words out here to the side and see if you guys remember some of these. All right, hopefully you guys remember whole numbers, okay? Whole numbers are anything that are positive and whole. So we've got things like 0, 1, 2, 3, and so on forever. There's the kindergarten numbers that you would have learned. Do you guys remember what integers are? Haley?
Positive and negative rational numbers.
I definitely agree with your positive and negative. What is it?
Positive and negative whole.
There you go. Positive and negative whole numbers. Positive and negative whole numbers. That is one we will use a lot this year. You want to know what an integer says, because a lot of times they'll say, give the answer to the nearest integer, and you'll have to know. Okay, then we have this idea of rational numbers. If you remember this, I will be impressed, because this is not one that, I mean, my digits class has been working on this a lot. Do you guys remember rational numbers? There's 3 things for rational numbers. Anyone? No? Okay. So, your rational numbers are any decimal that repeats, any decimal that terminates, anything that can be written as a fraction. Okay? So, when I say repeat, that means, obviously, if I have a decimal like 3.3 repeating. Okay? Now, what would pi be? Would pi fall in this category? No. Does anybody know what that's called? If you're not rational, you are, Brayden?
Irrational.
Irrational. Yes. Okay? 3.3 repeating would be a rational number. 3.3 repeating could also be written as a fraction. So that's why we say anything that can be written as a fraction is rational. Okay? Rational numbers can also look like square roots. Like I can have the square root of 16, because what is the square root of 16? 4. And 4 terminates. Anything that terminates stops. Okay, so that would be rational. So make sure you've written all. I haven't written very much down, but whatever I've written down, you'd want to write down. Does anybody remember the definition of a rational number? What did I just say? Did I say a rational number? Oh my goodness, I'm losing it. I mean absolute value. Holy cow. I looked right at it. Anybody remember what absolute value is? One person last hour remembered. This is something that you guys were saying, my teacher never showed me this. You guys remember seeing that on the pretest? Those straight bars? You guys see that okay? You guys remember that? Seeing that? You guys saying I don't know what that is? Okay. So this is absolute value when they have the straight bars like that. The absolute value of -3 is 3. And what absolute value is it is a distance from 0. Okay, So how far is negative 3 from 0? It's 3 spots. Okay? What if I said, what is the absolute value of 9? How far is 9 from 0? 9. Okay? So absolute value is always positive. Okay, so that's the other thing to remember. It's always going to be positive because you're always talking about distance. I can't say I walked from here to Walmart and I went negative 4 miles. That doesn't make sense. Distance is always going to be a positive number. Okay? All right. Let's go ahead and look at putting numbers in order. See what this says over here. This says, tell whether each number in the list is a whole number, an integer, or a rational number. Then order the numbers from least to greatest. So let's first of all go through and label what each of these is. So what would you call this number right there? Is it whole? No, it's not a whole number. Is it an integer? Why is it not an integer? Because it's not whole. Integers have to be positive, negative, whole. Is it rational? Yes, because we said rational numbers can be fractions. So this is rational number. We're just going to put rational. Okay, what about 0.25? Rational, good. What about 1.3? Rational again. Well, this is kind of silly. And the last one is also rational. Hated it. Okay, now it wants us to put them in order. Now, you can either think about this common sense, because you already know the negative one is going to be the smallest, okay? Or some people prefer to put them all into decimals, and that is fine too. Do you guys remember how to change a fraction into a decimal? You divide. So you take 5 divided by 4, and that would give you a decimal. 1 divided by 8 would give you a decimal. I know that negatives are always going to be the smallest, so I know that I need to start with this number. So I'm going to start with the negative 5/4 to put it in order. And then I know that 1.3 is larger than 0.25, and this is over a whole, and 1/8 is not even close to a whole. So I know that that 1.3 is going to be the largest. So I can go ahead and put it here if I want. And then I just got to fill in my other two in the middle. So I have 1/8, and that's where I was saying if you want to go ahead and change that into a decimal, you can. Here's my calculator. So if I wanted to go ahead and say 1 divided by 8, I could, and get 0.125, because that helps a lot of people to have that like that. So this is 0.125. So this is 12.5 cents. This one is 25 cents. So this one's going to be next, so 1/8, 0.25. Okay, questions on any of that before I keep going? Alright, this says for the given value of A, and this is tricky, it says find the opposite of A, or a negative A, and the absolute value. So I should have 2 answers on both of these. So I think what I'm going to do here, to kind of cheat myself a little bit, is I'm going to make this kind of into a little table here. And I'm going to go ahead and say, in this column, I want everything that's the opposite of A. And then this column, I want the absolute value of A, like that. If you want to do this on your homework, that's fine too. Okay, so this idea of negative A or opposite A, you can really think of it however you want. But do you guys all agree with me that negatives are the opposite of positives? Yeah, that's what it's saying. So it's saying that. Or if you want to think about this, that's okay too. If you want to think about it as a negative 1 times A, that's fine, because what is negative 1 times negative 5? Positive 5, right? Okay. Well, what's the opposite of negative 5? Positive 5. So whether you want to think about it as opposite or you're multiplying it by times a negative 1, either way. Okay? So again, this is the opposite. What's the opposite of 6.5? Negative 6.5. What's the opposite of negative 4.5? Positive 4.5. Okay? Alright, now we're going to get into absolute value. What did absolute value mean again? It's always positive, right? Because it means the distance from 0. So how far is negative 5 from 0? 5 places. How far is 6.5 from 0? 6.5 places. How far is negative 4.5 from 0? 4.5. Okay, so that's the difference between those two symbols. So now we're going to actually try to use it. Okay, so here's what we have to be able to do. We have to be able to plug in a negative 3 right here for our absolute value. So I'm going to plug in negative 3 in here plus 8. So what is the absolute value of negative 3? 3 plus 8, 11. And this is the work I would expect to see. I mean, I would expect to see that if that was your homework. That's what I'd want to see. All right, so let's try the next one. So we've got 8. Now, is this absolute value? No, that's just parentheses. That's just saying negative x. That's saying the opposite of x. So if x is negative 3, the opposite is 3. Does that make sense? Okay. All right, and then the last part, notice we have an absolute value here, and we have the opposite here. So, and I've got the opposite of inside of the absolute value. Okay, so x was negative 3. This is the opposite. So inside here, is it okay with you if I just put a 3 like that? Because that's the opposite of that. Put it there. Okay. Plus, the opposite would be 3. Does that confuse you guys too much? Okay, absolute value of 3 is 3, so it's still 3 plus 3, which is 6. All right, last part that we're going to look at. I'm going to zoom this out just a little bit. Hopefully. There we go. Okay. Here's where you see all this kind of junk in real life, and it's your bank account. Okay? And it says the activity on your bank account during the week-long period is shown in the table. A positive amount indicates a deposit, and a negative amount indicates a withdrawal. Which transaction increased the amount in your account the most? Which transaction decreased the amount in your account the most? Okay? So imagine that, and the way that I'm going to do this is I'm going to say that you went from here, this was your transaction, you added this, you took this out, you added that, you took it out, you took it out, you added that. Okay? So does anybody know when it says which transaction, which transaction increased the amount in your account the most? Which one would have increased your account the most? Colby? 3. The 212? Okay, and which one would be the least amount then? Which decreased your account? That's what I'm trying to say there. Connor? Number 4. So this would have been the decrease. All right, when we get into the next section of this 2.2, we're going to do, first of all, harder ones like this, and we're going to do more of the adding tomorrow. But I want to make sure we were fine on this before we get into that.